Students, welcome to your last unit in geometry. This is area and solids. Preview video 8.1, area of the quad family tree. Let's not skip this step. You want to go ahead, take a deep breath and inhale. Deep breath, hold. And exhale. You need to do some pretty light work. So this entire unit is very practical. We're going to be talking about the area of things, and we're going to talk about the volume, area and volume. And we're going to start with the quad family tree. But before we do that, let's recap what we have done. So this page says below a circle is inscribed in a square. The side length of the square is 12 centimeters. Find the area of the shaded region in exact term, no decimals. So I like you to pause the video, do this on your own, and then get a red pen and correct. Pause the video. All right, students, welcome back. I should see red pen markings now. You will get marked down if you don't show corrections. So let's look at what you have here. It says our side length of the square is 12 centimeters. So our icon equation here for the shaded region is going to be square, the area of the square, minus the area of the circle. And if you find both of those and then you subtract, you get the area of the shaded region. So there's your icon equation. Area equals length times width. Area equals pi r squared. Take a look at what we have. If it's a square, length, width, that's simply going to be 144. And if you go like this, it's also the diameter. So this should have been really easy. Your radius here is 6. 6 times 6, 36 pi, minus, check for units, centimeters squared. And because it's exact form, you can't go any farther than that. So it's 144 minus 36 pi centimeters squared. Let's start with the most basic thing. You probably learned this way back in 3rd grade. Area of a rectangle is going to be the length times the width. That's probably the version that you learned around 3rd grade. So length times width. All right. Now, the only way I want to caveat that, we sometimes call this, there's a right angle here. Instead of length times width, we call it base times height. Now, this would be the height. Base and height always makes a right angle. Base and height always creates a right angle. So in every equation you see for the next 3 weeks, wherever you see an H or a height, there is always a right angle implied. Be aware of that. So the word height or the letter H in an equation always creates a right angle. Now, do this with your hands. Make like a rectangle. A rectangle is length times width. Push it sideways. Guess what? Parallelogram is just a rectangle shoved sideways. So it's essentially the same equation. So a parallelogram is a rectangle shoved sideways. But remember the fact that height always creates a right angle. So in a parallelogram, this slanted edge is not going to constitute the height. Your height is going to drop down inside at a right angle, or you can take it from this outside edge straight down. So your base is the side that meets the height. Base times height. Base and height always creates a right angle. So far we have two of the quad family tree members, area of a rectangle and area of a parallelogram. Both of them are base times height. I'm going to do a couple problems, and then you are going to do a couple problems. Finger track and read. So take here, finger on the paper, lips. You read with me out loud right now. Go. Underline, we have the base, twice the height. Perimeter is 30. What is the area? You don't start with what you want. We want the area. So we'll write down our equation for it, even though we're not starting there. Area equals base times height. And our base here would be these guys. And your height meets them at a right angle. Length times width. In a rectangle, base and height, length and width are interchangeable. And it says the base length is twice its height. So the base is twice of the height. The base is twice of the height, which you would know as the width. So we're going to have two heights here. This is height, this is height. We don't have either, but we do have the perimeter. And perimeter is going to equal length plus width plus length plus width. Let's figure out what we have here. Our perimeter is 30. And our length is two of the heights. Our width is the height. Two of the heights. Our width is the height. 30 equals 6 heights, divided by 6, of course, and height equals 5. So that means this is 5 feet, and this is 10 feet. 5 feet, 10 feet. So your base here is going to be 10. Your height is 5. Length times width is going to be 50 feet squared. Very important. If there's units in your problem, there are units in your answer. An area is in 2 dimensions. There's another one. It says, finger on paper, out loud, read. So we have the area of a parallelogram. The base length is 12 centimeters. What is the height? Let's draw a picture. Parallelogram. And we are told the area of the parallelogram is 72 cm squared, and our area is given equation-wise. Area equals base times height. Let's put in what we know. It says the base length is 12 cm. The height we do not know. There's our unknown. Let's circle, plug, chug. You circle, you plug that in here on the left. And of course, we have 72 equals your base, which is 12, times your height, which is unknown. And of course, 6 goes into 72. 12 goes into 72 6 times. So your height is going to be 6, check your units, cm. So before we go on to the rest of our quad family tree, which is 4-sided shapes, all 4-sided shapes incorporate triangles, 3-sided shapes. So just kind of as a recap here, how do you find a parallelogram? And of course, that's going to be base times height. All right. Now, if you take a parallelogram and you divide it in half, you can see the shape you're going to get is a triangle. So the equation for area of a triangle, super easy. It is simply the base times the height over 2, because a triangle is half of a parallelogram. How do you know which one's the base and the height? Again, base and height always creates a right angle. Now, it's a little bit different seeing this when you have 3 different triangles, acute, right, and obtuse. I just want to notice something. When you have an acute triangle, which is what we have right here, in an acute triangle, every angle less than 90, the height is inside the triangle. If you make the triangle obtuse, meaning an angle bigger than 90, notice angle C is now obtuse. The primary height is now outside the triangle. Keep that in mind. So acute, it's inside. Obtuse, it's outside. And to make things really interesting, in a right triangle, the height is on the side itself. So in an acute triangle, it's in. Obtuse, it's out. In a right triangle, it's on. That's why there's a special area equation for a right triangle. So in an acute triangle, to find the area of an acute triangle, it's going to be this base times the height. Height always creates a right angle, and height is always creates a right angle, and it's going to be divisible by 2. All of these are going to be over 2. Base times height over 2. So the area of the base times the height over 2. In an obtuse triangle, your height would drop down from the outside to make that right angle. There would your height be. And your base is the side that has an imaginary line that meets it, kind of this way, but it would only be that length. That is your base times height over 2. In a right triangle, there would be your base and your height, because it meets at a right angle over 2. Same equation, all 3. In that right triangle, a little bit of a unique situation. The base and the height is also called the legs. So you can find the area of a right triangle as one leg times the other leg over 2. Leg times leg over 2. That's only for a right triangle. Trapezoids. Now, if you take a look at a trapezoid is essentially 2 triangles. Right? It's 2 triangles. Each triangle is going to be base times height over 2. Base times height over 2. Each of the triangles. They both share the same height. Height is going to drop down straight here. So the height of both triangles is right there. What's different is in one of them, the base is shorter, and the other one, base is longer. So how we handle that for a trapezoid is this. Trapezoid is the area of two triangles. Every triangle is base times height over 2. The height is exactly the same. But the bases are different lengths. There's a longer one and a shorter one. So what we do there is we average the bases times the height. So the trapezoid equation I want you to remember is the average of the bases. One base, which would be the longer one, or the shorter, it doesn't matter which way you start with. Base plus base over 2 times the height. It's the average of the bases times the height. Okay, so recap with me. Make your hand. We're going to pretend it's a rectangle. Ready? Make a rectangle. Say base times height. Now push it over, parallelogram. Also base times height. Ready? Triangle. Half of a parallelogram is base times height over 2. Trapezoid. Make one longer, one shorter. Say average the bases times the height. Average the bases times height. So base times height, triangle, base times height over 2, trapezoid, average the bases times the height. So in our quad family tree, this is what we have so far. Area equals, area equals, area equals, area equals, area equals, area equals. In a parallelogram, it is base times height. For a rectangle, also base times height. Square is also base times height. Now, a square technically can have another version of this, but because base and the height are the same thing, we could also just say side squared. Trapezoid, average the bases. Base plus base over 2 times the height. Now, the only two left here are rhombus and a kite. And a rhombus and a kite have something in common. They have diagonals, which make a right angle. Because they have this unique quality, diagonals that make a right angle, they have a unique equation. And it's related to the triangle equation. And it's going to be diagonal times diagonal over 2. So diagonal times diagonal over 2. Diagonal times diagonal over 2. So a kite is diagonal times diagonal over 2. A rhombus is also diagonal times diagonal over 2. A square also qualifies as a rhombus because, wow, this pen is not working well here. Has a right angle there. So a square could also be diagonal times diagonal over 2. There, our quad family tree is complete. Let's go ahead and do a couple practice problems together. Read out loud, lips moving. Says we have a kite with an area, longer diagonal 15, find the shorter diagonal. So we draw a picture always. There's a kite. And I have a longer and a shorter diagonal. It says our area is 90 cm squared. A longer diagonal is going to be 15 Oops, hang on. We should write our equations out, which I did not. And it is area equals diagonal times diagonal over 2. And we have 90 equals one diagonal. The longer one is 15. So 15 times the other diagonal, we don't know, over 2. Cross multiply, solve. We end up with 180 equals 15 times D divided by 15. And 15 goes into 18 one time. And that's going to be 3 left over. Let me do this. So what I'm doing in my head, you're seeing like this. For those of you who weren't tracking there, 15 goes in there once, 3, 15 goes in there twice. So our other diagonal is 12, check for units, cm. So a couple rules here. Equations have 2 sides with an equal sign. Always write down both sides of an equation. Area of a trapezoid is 160 meters squared. The bases are 12 meters and 20 meters. Find the height, question mark. Let's draw a picture. We have a trapezoid. We already know what our bases are. So we have a shorter of 12 and a longer of 20 and an unknown height. And our area equals base plus base over 2 times the height. Circle plug check. We have 160 over here. We have 160. By that 32 divided by 2. Whoops, that's not 18. Make sure you're paying attention. That's 16, of course. And we find that our height is 10. Really nice about this, you can always plug it back in and check it. Probably a good idea to do. These 2 problems you're going to do on your own. Pause the video. All right, students, you'd have a red pen here. I'm going to be looking for red pen corrections. If you are correct, some sort of star, smiley, check, some sort of acknowledgement you did it correct, as well as a little, what's one key thing you want to remember? What do you want to remember? Okay, and if you get it wrong, I expect you to do the work again and also, again, star it and ask yourself, what do you want to remember? So checking here, we have a rhombus, side length of 5 feet. Ooh, this is going to get a little bit more interesting. We have a rhombus, 5 feet. The longer diagonal of the rhombus is 8. Shorter of the diagonal of the rhombus, you don't know, find the area of the rhombus. Okay, so you might have gotten a little like, wait a minute here, what happened? So we know it's going to be area equals 1 diagonal, which is the longer one, times the other diagonal, which is the shorter, over 2. Problem is, where's our other diagonal? This is the trick you needed to know here. Okay, these pieces are going to be 4 and 4. obviously. And there's a right angle here because it's a rhombus. And to find this little piece, green squiggle, call it x. That's going to be x squared plus 4 squared equals 5 squared. So x is going to equal 5 squared minus 4 squared square root. 25 minus 16 square root of 9, 3. So you should have gotten 3 and 3 here, which means your one diagonal, you already got it, was 8. Your other diagonal would be 6 over 2, 48 over 2, 24, check for units, feet squared. Again, write a note if you overlook that right triangle. Find the area of the shape below. This seems easy. It's just a couple different rectangles. Couple ways you could look at this. You could do what I call negative space, where you find the area of this imaginary outer rectangle. Okay, which would be that one. And then you find the area of this little rectangle, which would be this one. And then you subtract. That would be one way to do this. Let's do it that way. So we have 5 times 6, which is 30 feet squared, minus. And this little piece right here, you're like, I don't have it, but wait, you do. The whole thing's 5. From here to here is 2. That would make this 3. This whole thing is 6. This is 3, so that makes this 3. So 3 times 3, that makes that 9. That's going to be 21 feet squared. That's called negative space, if you will, because you find that area and you take it away. Another way I would call positive space, where you're adding things. So you slice and dice it in some sort of direction. So this one I'm going to do horizontally. I'm going to go like this. And we add instead of subtract this time. Find our areas here. This one's going to be 6 by 2. So 6 by 2, that's 12 feet squared. And we're going to add. And this right here, you're like, wait a minute, I don't have that. We'll go back down here again. The whole thing's 6. All right. And that means this right here must be 3. So that's 3. And this is going to be 5 minus 2. So this is 3. So this is 3 and 3. So that's going to be 9 feet squared. You add 12 plus 9. Oh, looky there. It's the same thing. 12 feet squared. But wait, there's more. You could break this up vertically, going this way, like so. And you add, of course. Take a look here. Our length is 5. Our width is 3. So it's 15 feet squared. You go over here. This whole thing's 6. That's 3. So that makes this is 3. And 2. So that makes this 6 feet squared. 15 plus 6 is, and lo and behold, we are back to the exact same thing. Summarize what you have learned today, the key ideas.